Hello students, welcome to my channel. So in today's class, we will discuss about gamma function property 3. Let's get started. So this is property number 3. So prove that gamma of n plus 1 is n factorial, where n is a non-negative integer, which means it includes 0. Non-zero integer means 0 is not included here. So it includes 0, 1, 2, 3 towards positive infinity. Okay, non-negative integer means. Now, how do you prove this? So, to prove before proving this, so one should have to remember and recall the properties like property 1, property 2 of a gamma function. So, previous class we discussed about property number 1 of a gamma function is gamma 1 value always 1. Property 2 of a gamma function is we have property 2 of a gamma function is gamma of n is equal to n minus 1 multiplied by or m minus 1 times gamma of n minus 1. So it is minus 1 if n is greater than 1. This is property 2. It is of a gamma function. Now apart from that, we need to remember here n factorial definition. What is n factorial? It's the product of first n natural numbers, which means n times n minus 1 times n minus 2 successively, so on continuation, like dot 3 dot 2 dot 1. This is called n factorial definition. Okay, these three properties, so two properties followed with factorial, these are mandatory things to prove this result. Okay, how to start this? So let's get started. The proof is given like this here. So consider LHS, consider left hand side. So left hand side is gamma of n plus 1 we have given. Now it is equal to, we need to prove that n factorial. So this gamma of n plus 1 is nothing but I will apply this property 2 here, which means, so for gamma of n, the property 2 says n minus 1 times gamma n minus 1. Similarly here we have n plus 1. So I have to apply same rule n minus 1, which means n plus 1 minus 1. First step I will write here n plus 1 minus 1 times again gamma of n plus 1 minus 1, because in place of n we have n plus 1 is there. That's the reason. So we have to be write like this. So here applied property 2. Property 2, it is already discussed in previous video lecture. So property 2 I applied here. Okay, after that simplification, n times gamma of only n, because plus 1 minus 1 cancel out. Again it's exactly property 2 format, this one. Now again apply. So here we need to apply successively 2 to 3 times this property 2 only, which means n minus 1 times again gamma of n minus 1. So I will mention here applied again property 2. Property 2. Okay, once again, so sorry, this n also followed. N is multiplied with n minus 1 times gamma of n minus 1. Again apply the same rule, which means property 2. So n times n minus 1 remains the same. Now this time n minus 1 minus 1 means n minus 2 times gamma of n minus 1 minus 1 means n minus 2. Okay, so this is again we applied same property number 2. So the next step what I will do, I'll take new page. Gamma of n plus 1, which is equal to, we can say, n times n minus 1 times n minus 2 times. Okay, so if we keep on apply same property 2 successively, so you will get here 3 dot 2 dot 1. So this gives exactly the definition of a, so you will get here successively means last value is gamma of 1 will left. Okay, in that case, so what happens, we know the value of gamma 1. Gamma 1 is how much? 1. If we apply the rule, it gets like this, n times n minus 1 times n minus 2 times, here next value n minus 3 times, so on 3 dot 2 dot 1. Earlier here gamma of 1, now it has become 1 because of property number 1. Property 1, applying property number 1 here. So already written, this is nothing but n times n minus 1 times n minus 2, so on up to 3 dot 2 dot 1. This is nothing but definition of a n factorial. So we can say here n plus 1 left side equal to n factorial. Here n is a positive integer, positive integer, hence the result. So n is a positive, So we can say non-negative positive integer, non-negative, or simply say non-negative integer. I'll remove this. Non-negative integer means it includes, okay, positive only. Okay, that's the proof of the given theorem. So after that, so we'll discuss few points here under note, under note. Okay, so if you observe here, the first point I'm writing, gamma function is not defined, not defined for n equal to 0 or n equal to 0, we can say, and negative integers, and negative integers, negative integers also, it is only for negative integers. For negative fractions it is defined as of now. So here you can so use the definition by substituting n equal to 0 or n equal to -1, n equal to -2 towards minus infinity. You will not get the integral value, definite integral value, which means, so there uh, definite integral does not exist. So which means gamma function is does not exist for 0 as well as all negative integers. So the next property, very very important property, this one, first one. The second property, so already here, so last class we discussed the property number 2. The extension of property number 2 is if n is a, if n is a, n is a, so for positive integers already we discussed, same one I will write again. If n is a positive integer, positive integer, positive integer, so here which means gamma of n plus 1 equal to n factorial. It is defined for positive integers and non-negative. Okay, we can say this is generalization for non-negative integers also, which means suppose that as of now for positive integers gamma n plus 1 equal to n factorial. Now the next one is, the next one is if n is a, if n is a positive fraction, positive fraction sometime, okay, the here n value is a positive fraction. So there it is defined like this, gamma of n equal to, this could be writing n minus 1 n times n minus 1 times, so we have n minus 2 times, so on, so dot, okay, n minus r times gamma of n minus r, n times n minus 1 times n minus 2 times n minus 3 times, so on, n minus r times n gamma of n minus r, if n minus r value greater than 0. This is the rule for positive fractions. We will do some examples in next video lecture. So here number 4 is, so here if n is a, if n is a negative, negative fraction, negative fraction, the rule is given like this, gamma of n equal to gamma of n plus 1 divided by n. This is the rule for negative fractions. So finally, so you have to be remember, you must remember for negative fractions, so gamma of n equal to, it could be writing like this, gamma of n plus 1 by n. For n is a positive fraction like gamma 11 by 2, gamma 13 by 2 for positive fraction examples. We can do okay application problems in next video lecture. As of now, so we can use, I have given here only rules to remember. So for negative fraction, for example like gamma minus 3 by 2, it's a negative fraction. For that case you can apply this rule. For positive fractions apply this rule. Okay, it is meant for only positive integers including 0 also, gamma n plus 1 equal to n factorial. But especially this property says gamma function is not defined for 0 as well as for negative integers. Okay, so after that, this is what we already proved, and this is property number 1, property number 2, this n factorial. Using these three results we are deriving gamma n plus 1 is n factorial where n is a non-negative integer. This is the, okay, proof of property number 3. Okay students, thank you so much.